Today on the Why of Math, we're going to be discussing why L'Hopital's rule works. What do the derivatives of a function have to do with the limit of a ratio of functions when both functions go to 0 or infinity? The answer has to do with the Taylor series of those functions in the vicinity of the limit. If a function approaches 0 at x0, then values of x minus x0 much less than 1. The value of the function will be very close to the first derivative at x0 times x minus x0. In other words, the function is very nearly linear over very small intervals. Therefore, the ratio of the first derivatives at the limit will determine the ratio of the functions at the limit. And if the first derivatives are both 0, we go to the second derivatives. If the second derivatives are both 0, we go to the third derivatives, and so on, until we get to a derivative that does not give us an indeterminate form. Now, what if both functions go to infinity? Well, since we've already proved that L'Hopital's rule works for indeterminate forms 0 over 0, we can rearrange an infinity over infinity form to get 0 over 0 by taking the reciprocals of both functions. I have that written out here. Now, the derivative of the reciprocal of the function is the negative of the derivative of the function divided by the original function squared. Now, as noted here, if you take the derivative of the reciprocals of g of x and f of x, that gives us f of x squared times g prime of x over g of x squared times f prime of x. Now, setting the limit of that equal to the original function ratio means that f of x times g prime of x over g of x times f prime of x limit as x approaches c equals 1, which in turn means that the limit of f of x over g of x as x approaches c equals the limit of f prime of x over g prime of x as x approaches c, proving that L'Hopital's rule also works in the infinity over infinity indeterminate form. That's all for today. Remember to like, share, and subscribe, and leave any questions in the comments section. Thank you.